Now, let's look at the core of the exercise, which presents a scenario of a student performing length measurements and asks to evaluate the correctness of statistical statements based on Gaussian error analysis. The task involves understanding concepts like mean, standard deviation, and standard error to select correct statements from the given options. The assumption of random errors and a Gaussian distribution is key. Alright, let's dive into the setup of the error analysis problem. It introduces a scenario where multiple measurements of a table's length are taken. This provides a practical context for applying statistical concepts related to measurement errors. Here's the data set. 5 measurements of the table's length are provided. These values form the basis for all subsequent calculations. Each measurement is subject to random error, which is a key assumption for applying Gaussian error analysis. These are the specific measured values in centimeters. The variability among these values reflects the presence of random errors. These are used to estimate the best estimate of the table length. The assumption of random errors is crucial because it allows the use of statistical methods to analyze the data. The assumption of Gaussian distribution is critical. In real-world measurement scenarios, errors often follow a normal distribution. Now, let's look at the multiple-choice statements. Each option pertains to a different aspect of the statistical analysis. This option is testing the understanding of how to compute the best estimate of the measurement, and in most cases, it's the mean average of the measurement values. This option checks if the standard deviation calculation and understanding is correct. Standard deviation is a measure of the data's spread. This option evaluates the correctness of the standard error of the mean, SEM, computation. SEM reflects the precision of the sample mean. Now, let's look at confidence interval. This tests the understanding of Gaussian distribution. Now, let's look at the underlying assumptions that are necessary for solving the problem. These assumptions are important to consider in many statistical analyses and modeling that will follow. Now, let's define the goal to find out which statements from the options are actually true. The task is to identify and select all the statements that are statistically correct based on the measurement data and the given assumptions.